Morning. My name's Jeff Hilland. I'm a distinguished technologist at Hewlett Packard Enterprise. I'm also president of the DMTF and co-chair of the SPDM working group. Vlad, you want to introduce yourself?
Hi, my name is Vlad. I'm managing firmware engineering team at Google.
So we're here to talk to you today about an auxiliary management controller. It's similar to the previous talk. This one's been an open work stream under the manageability project for a little over a year. We started about 2 years ago, and the SMC spec has already been published about a year ago. The problem is, you know, every vendor out there, every device, right, is, you know, every PCIe, CXL, or other component has its own manageability interface. Ooh, can you turn that down? I can't even read it. Every BMC's got to have special code to manage that, because all the options, you know, some people will do PLDM, some people will do their own proprietary model. There's a lot of different options and different commands, and if you look inside of the PMCI specs themselves, there's this particular command might have this, that, and the other. And we found a bunch of different vendors doing it pretty much a different way, and every time the BMC would have to react and change the code inside. And of course, PMCI helps that. You're not having proprietary code, you're implementing an industry standard. But again, with all the options out there, you know, how do you do SPDM? If you look at SPDM, you know, what kind of cert are you doing? Are you doing a TPM in there? Are you using, you know, what commands do you support? Do you do bulk transfer? Same with firmware update, RDE, the FRU data, everything else. So what we decided to do is you know, since no single spec existed out there, that basically took a profile out there for all the different devices in the ecosystem, and there was no open source project out there that helped a device vendor adhere to all of those standards, you know, we thought we'd take a crack at that. And every vendor had a different solution already, right? Meta had OpenBIC for servers. Google has Mini BMC for storage. I work for HPE. We had our own. Dell has their own spec. And that really drives the device vendors nuts, because in order to you know, be accepted by any of these vendors, you've got to adhere to their spec. And so you end up with this M times N problem for every device out there and every system you're sticking it in. You've got to have special code. And then, of course, all the BMCs are on the other side trying to have communication with all these devices, and they've got to have special code as well. So what we did was we got together with Google and some other folks and developed something that used to be called the SMC spec. It was a satellite management controller spec, and if you go out there and look, you can find it out there called that. The problem with that is people thought we were managing satellites. And that would have been cool to do from a server, but no, the BMC isn't managing satellites. Instead, it's an old IPMI term, your device was the satellite, right? So what we did was renamed it a few months ago to Auxiliary Management Controller, not to be confused with the Accelerator Management Controller of the previous talk. Unlike them, this one's out in the open. You can find the spec out there in the GitHub. You can go out there, and if you want to do issues and pulls, if you want to join, if you want to make the spec better or change things in it, if you want to see your device supported in it, you can join us and help out. But basically what it is a profile for the PMCI specs, right? Is, you know, here's the line item veto, don't do this command, do it this way, that kind of stuff. There's a couple of different ways to do it. You can put it with an interposer chip down on your device, or if your device has room for firmware in there, you can go ahead and put it just in code. And really it's either way, depending on what your solution requires. The whole point being really is we're looking at a lower cost way of doing things, lower power requirements, and a complement to the way the BMC does it, right? We're trying to add it, you know, in existing space, but if you can't, that's understandable. So again, you know, we're looking at all the auxiliary devices that you'd stick in a system, accelerators, storage, controllers, drives, NICs, DPUs, SOCs, whatever. It's not really meant for a replacement for the BMC. Think of it as a provider architecture where you're providing all that information into a BMC that then is going to spit that out redfish on the other end. So what's in it right now? It's a bunch of prescriptive requirements on, you know, tables and tables of do this and don't do that, and what to do over I2C, how to do MCTP over I2C, which commands you need to support. For PLDM, which opcodes you need to support there. It's got SPDM requirements, RDE requirements if you support that. So it goes down to each individual level. And then there's conformance paragraphs in there around thermal properties, fan speed, Fru ID, supporting software inventory, and the rest. There's a bunch of stuff missing from the spec, though. We don't really have a test tool. There's some folks working on PMCI level test tools, and that's a great idea, but really, if you're trying to eat this stuff in the ecosystem, you're trying to eat it through Redfish. So while you've got a good way of helping the BMC out, really what matters is the data that's getting spit out the other end. Now, the OCP profiles workstream has that, right? You can use the Redfish interop validator to do Redfish profiles and check the data that's coming out, if it's RDE or PLDM or however your BMC is translating it. You can validate the data right there. And so what we're going through and doing is looking at drives and looking at subcomponents and adding those. There's a Ethernet NIC profile that's in there right now that I contributed about a month ago, a little over a month ago. We're working with the Redfish forum to clean some stuff up in the ACD model, the Advanced Communication Devices model, in order to get that supported and passed by OCP. So we'll hit drives next. As soon as we get things straightened out. But we think that'll help a whole lot. The other thing that's missing is, conformance test, right? So, that should help there. And the last thing that's missing is code for the AMC side of the wire. And to tell you about that solution, Vlad's up next.
Hi, guys.
Okay, just hit the space bar.
Oh, Hi, guys. So Jeff presented general concept for what we call now AMC, and I will be talking a little bit about project we have at Google. I guess I have a little bit more time. So as Jeff mentioned, we still have BMC. We have up to 4 mini BMCs connected to BMC, and every mini BMC manages storage hard drive tray. So it allows us to save a lot of space, it allows us to save a lot of money, and therefore it can be more scalable. So we have the same functionality, we still have GBMC, with what we call regular BMC, we call it GBMC, and then we also have mini BMC, which can provide specific control. We're doing this mini BMC running a little bit smaller micros than regular BMCs, and we're running Zypher. There is a typo, 1 R is missing on this presentation. Zypher is a real-time operating system, it's open sourced, and every vendor can have access to it. There are 3 options to build application based on Zypher, from Zypher repository application, workspace, or freestanding application. For our project at Google, we chose to work with workspace application. And I will be talking more about implementation details in this presentation. So we decided that we technically will break it down into a couple of repositories. One repository will contain the Zypher itself, all the drivers, and every vendor will be responsible to maintain it. Other repository will contain generic stuff that everyone will, whoever wants to implement something based on AMC will be using. Like Jeff mentioned, communication interface with BMC will be RDE, so you don't need to implement it all over again, you will be able to use it. There are some thermal framework and some other timers and stuff like that that can be generic, but there will be some proprietary code that every company will have, and this will be in different repository. This is the main structure of the repositories, and this is exactly what I explained. We have 3 layers. One layer is everything common, and then there will be vendor specific. By vendor specific, I mean Zypher drivers and everything that vendor needs to implement specific for this micro. And then there will be projects that every company will have to take those 2 repositories and add their own logic. Yeah, I think that this was your slide. Yeah.
Oh, that was quick.
Yeah, actually.
See if it works. Yep. Well, that was quicker than we had planned. So again, the SMC, now called AMC workstream, it's under the hardware management group. We've been working on profiles together, and we've got the spec opened up. We're ready to do a 1.1 version. So if you have any issues, questions, or things you want to see in the spec, things you don't like in the spec, feel free to join, and it's an open group. It's not under CLA. We meet once a month, and it's just like any other GitHub repo, right? You go through issues and pulls and till you're done. So please join if you have it. And again, the open source contribution from, is it out there on the GitHub yet?
Yeah, by end of the month it will be out on the GitHub.
All right. Any questions? All right. Thank you. Oh.
Yeah. For this demo here, this is a productized thing, or is this something that there's an emulator for? Could I download it and put it on a Arduino or something? And
You mean the code?
yeah, the Zephyr application.
Yeah. So the Zephyr repository, you will have to get it from the vendor, because this will need to be adjusted for this particular microcontroller. There will be another layer that you will be able to download, and then you will get all the RD framework and some other frameworks. And then on top of it, you will need to build your business logic. Like, for example, we don't know how many sensors you will have. We don't know what you want to do with this information. You will be able to get it, pack it in RDE, and send it over to BMC.
Is it primarily an RDE client?
We're using RDE, yeah. There are some discussions, but it's basically USB, MCTP, PLDM, and then RDE.
Okay.
There are pros and cons. We chose RDE.
Yeah, cool. I'm interested in the idea of being able to run it completely as a simulation or an emulation platform. That'd be interesting.
You're still going to have to come up with the adaptation layer at the lower end, right, to provide the data into Zephyr. Yeah. Yeah, but that should be all you have to do. All right.
Questions?
If there aren't any other questions, we've got about 5 more minutes. All right.
All
Any
right.
questions? Thank you very much.
Thank you.